had reached their goal. The very bottom of the Marianas Trench. The depth gauge, with a reading of 35,800 feet, nearly 7 miles below the surface, confirmed the sonar findings. Squeezed inside their bubble of breathable air, the two explorers were closer to the Earth's center than man had ever been.
We took a self-portrait. That's the picture that you see. Said we're going to do it, and we did it.
But there was work to be done. Walsh and Picard wanted to make detailed observations of the enormous trench. Unfortunately, the Trieste stirred up a cloud of fine, powdery sediment from the sea floor that obscured their view.
It's like being in a bowl of milk at that point. So, realizing we weren't going to see anything, we decided to go on back up to the surface.
Off the island of Guam, the Trieste surfaces after a descent into the Marianas Trench.
After 9 grueling hours underwater, Walsh and Picard returned to the surface on January 23, 1960, and officially entered the record books for the deepest dive of all time. To this day, their extraordinary feat has never been repeated. The mission was a success, but the mystery remained. Geologists still didn't understand what could have formed the immense trench. And if they couldn't find the answer inside the trench, they would have to look elsewhere. Perhaps there was something somewhere on the ocean floor that might explain the trench's origins. Throughout the 50s and 60s, a team of geologists led by Princeton's Harry Hess compiled sonar data from all of the world's oceans. It was as though they had pulled out a giant plug to drain away all the water and expose the ocean floor. Their maps revealed that the Marianas Trench is just a tiny fraction of a network of enormous underwater canyons stretching right around the planet. But that wasn't all. Running parallel to the trench, on the other side of the Pacific, the map showed a giant underwater mountain range, the East Pacific Ridge. And this, too, is part of a global network, a 40,000-mile-long chain of mountain ranges that ring the globe like the seams of a baseball, to make the largest geological feature on Earth. It was a major development in the investigation, one that scientists hoped might explain the trench's formation. The next step was clear. Investigators needed to understand whether there was a connection between the trench and the East Pacific Ridge. The breakthrough came from the unlikeliest of sources. During the Cold War, the U.S. built a vast network of underground seismometers to pick up atomic bomb testing around the world. Inadvertently, the seismometers also detected naturally occurring earthquakes. When geologists plotted these on a map, a pattern emerged. The earthquakes were clustered along the ocean's ridges and trenches. It was a discovery that transformed our understanding of the Earth. Geologists realized the friction that causes earthquakes comes from movements that must be occurring deep beneath the ridges and trenches.
With this great investment in seismology, it became possible to locate very precisely where earthquakes had occurred. And it was these things, the precise location, the depth, and the motion, that really gave the outlines of plate tectonics.
It was the birth of an extraordinary new theory. The solid layer of rock, the crust on which the land and ocean sits, is broken up into a series of vast slabs that geologists call tectonic plates. It's these plates that are moving, grinding past each other and triggering earthquakes. The underwater ridges and trenches sit on the boundaries between tectonic plates. The East Pacific Ridge and the Marianas Trench lie on opposite edges of the Pacific Plate. The journey to discover what formed the Marianas Trench is accumulating additional evidence. The Trieste dived to the bottom of the trench and confirmed that it is the deepest point on the planet. Sonar maps then revealed the East Pacific Ocean ridge running parallel to the trench. To solve the mystery of the Marianas Trench, investigators needed to find out exactly what was happening at the East Pacific Ridge, and that meant exploring these vast mountains, 8,000 feet underwater. The pieces of the Marianas Trench puzzle are falling into place with the knowledge that it lies on the western edge of the Pacific tectonic plate. On the opposite side of the plate lies the East Pacific Ocean Ridge, part of an enormous chain of underwater mountain ranges that ring the globe to create the largest geological feature on Earth. Scientists had a hunch that this colossal ridge might help explain how the trench was formed. And they found a major clue halfway round the globe, where the ridge passed beneath the middle of the Atlantic Ocean. During the Cold War, the U.S. Navy developed a new technique to spot Soviet submarines. They scanned the seas with a tool called MAD, a magnetic anomaly detector, which could pinpoint steel hulls lurking in the deep. But they stumbled across something else. Running parallel on either side of the ridge, they found strange stripes of magnetic rocks, alternating positive and negative away from the ridge's peak.
Here's the mid-Atlantic ridge coming down through here. Almost perfectly symmetric on either side of that are these white and black stripes. These have often been called zebra stripes.
Geologists know that the Earth is like a giant magnet with a north and a south pole. But the magnetic poles aren't fixed. Every 300,000 years or so, the magnetic field suddenly flips 180 degrees. When the field flips, a compass that was previously pointing north will swing to the south.
This reversing of the Earth's magnetic field is a very interesting and exciting but very puzzling phenomenon for geophysicists to explain.
Scientists think this reversal explains the stripes either side of the ocean ridge. In the 1960s, geologists discovered that molten volcanic rock, known as magma, swelled up from deep underground to create the ridges in the Atlantic and Pacific. As magma wells up between the tectonic plates, it pushes the seafloor up and forms the colossal mid-ocean ridge thousands of feet high. When the rock is hot and molten, its magnetic minerals line up with the north-south direction of the Earth's magnetic field. As the magma cools, the minerals are locked in position. These rocks act as a permanent record of the magnetic pole's location when the rocks were formed. As more and more magma is forced up, the old crust is pushed away from the ridge and records the reversals in the Earth's magnetic polarity.
If you have reversals of magnetic polarity, then the seafloor acts sort of like a tape recorder and records these changes in magnetization. Then the pattern of magnetic stripes allows people to calculate the speed at which the plates are moving apart.
The zebra stripes are proof that over time, the seafloor in both the Atlantic and the Pacific is spreading away from the ridges at a rate of more than 2 inches a year. But geologists needed proof that magma created the ridge. If red-hot molten rock is forming the enormous mountain range in the Pacific, the surrounding water should be warm. In 1977, a team of scientists set out to discover whether this warm water really existed. Dudley Foster was the pilot for these historic dives.
It's been an exciting occupation because you're on the cutting edge of science. New discoveries all the time. Every cruise, there's a new group of scientists with new scientific objectives, and there's the exploration and the discovery. And that's really what puts the thrill in the job.
For weeks, the crew scanned the undersea mountains without success. And then they hit the jackpot. A bizarre pillar of rock, spewing hot, toxic gas.
And we saw the water was sort of shimmering, sort of like bubbling in a glass teapot or something. We stuck the temperature probe in there and measured 38, 39 degrees Fahrenheit, which was really amazing because the ocean's a huge heat sink. So to see something warm like that was kind of startling.
In these pillars of rock, the expedition had found the heat from the magma surging up from deep inside the Earth. It wasn't warming the water evenly along the ridge. It was channeled up through strange hydrothermal vents.
When you make these discoveries, you don't know how significant they are. The true significance of them maybe takes several years to appreciate. And this was one of those times.
For the investigation into the Marianas Trench, these vents are a decisive piece of evidence. They confirm that magma is continually creating new crust at the Pacific Ocean ridge. And magnetic zebra stripes prove that old crust is pushed away from the ridge towards the other side of the Pacific Plate, towards the Marianas Trench. But this presents scientists with a puzzle. If new crust is being created at the ocean ridge and the Earth isn't expanding, then the old crust must be disappearing somewhere else.
The reason that there's not getting bigger with seafloor spreading is because the same amount of seafloor is being destroyed in the Pacific.
Something in the Pacific Ocean is devouring the seafloor, and all the evidence points to the Marianas Trench. In the hunt to discover what formed the Marianas Trench, scientists now know crust created at the ocean ridge is being devoured somewhere and by something in the Pacific Ocean. They suspect the Marianas Trench is involved. But the proof would come not from the trench, but from these. The Mariana Islands, a chain of volcanoes that break through the ocean surface 200 miles west of the trench.